I really really liked Oppenheimer. I think you're a little bit of a comic book nerd or
Yeah.
fan. I call it amongst my friends. I call it like the Avengers of physicists.
Dun, dun,
It's
dun, dun.
it's so awesome because the movie has all the characters in it are real historical people
Yeah.
that I've been reading about. I've been reading their theories, working with their actual formulas, all of these things. So these are people that I've been hearing about for the past couple of years. And then to like see them on the big screen now, and then also see the personalities that I heard that they were, and I just thought it was really awesome. I
Wow.
really, really love that movie. Yeah.
You know what just hit me? They actually went and got an Avenger to put in the movie.
Which one?
Robert Downey Jr.,
Oh
Tony
yeah,
Stark.
right. Yeah.
People, good afternoon, it's good morning, good afternoon, and good evening. Wherever you are in this beautiful, wonderful world, I'm your host, John Sandiford, aka Jam Sandiford, and this is the SunSide Kingdom Show, the place where we highlight individuals hailing from the Dutch Caribbean that are true role models in whatever it is that they chose to pursue. Today we have with us a very special guest. We met actually just a few weeks ago, and as I was asking and trying to inquire about role models hailing from the Dutch Caribbean, beautiful island of Bonaire, that turquoise sea, the best diving spots in the world, it was unanimous that I had to interview this guy. And once I heard what he's up to, I thought, damn, I didn't thought I was going to meet someone that was actually busy in this field. So today we have with us Dylan Van Arneman.
Yeah.
I have that correct?
Yeah.
All right. A passionate astroparticle physicist. So some of you may have to Google what that means, but he'll explain it in a while. Hailing from Bonaire and Amsterdam, making significant contributions as a PhD candidate at the Dutch National Institute for Subatomic Physics. Damn,
Yeah.
that's some stuff that I only see in the movies, man. He's a young Cern scientist actively involved in the Atlas experiment with a mission to increase diversity in science by inspiring underrepresented communities. And that's all what we're here for, right? Mainly Caribbean people. That science is awesome and there's a need for diversity in the field.
People, welcome to the SunSide Kingdom Show.
All right, let's dive into early childhood. Where did you grow up specifically?
So I grew up, so technically I was born in the Netherlands.
Yeah.
But when I was about 4 or 5, I actually moved back to Bonaire, where my father is from.
Yeah.
So I don't really have any memories living in the Netherlands, honestly. So I would say I just fully grew up on Bonaire.
Yeah. And where's your mom from?
So my mom is from the Netherlands.
Okay.
Yeah. So I'm technically half Dutch, half Bonarian, but I really mostly identify as just full Bonarian, especially culturally.
Yeah.
Most definitely.
Yeah, I could imagine, especially if you've been there since 4 years old and you.
Yeah.
Once you spend significant amount of time on the islands, you're just going to be identified as an islander.
Yeah. The island fully shaped who I am today,
Yeah,
for
yeah.
sure. Yeah.
Awesome. So born in Amsterdam, grew up in Bonaire. So what was that like in the early days growing up on Bonaire?
Yeah, I mean, it was definitely a different experience from what I hear from my friends and colleagues here in Europe now, I think, because Bonaire is a very tiny island.
Yeah.
And especially back then, I think we had a population between 12 and 15,000 people or something. So it's a very, very close-knit, tight community. Everybody knows each other. Which has pros and it has cons, of course. But I'm sure that many Caribbean people can relate to this. It's not a Bonaire specific thing.
Yeah, for sure.
But also, I did notice, for example, if I compare it to some cousins that I had in the Netherlands, that the sort of things that we can do is definitely very different in terms of as a kid.
Yeah.
So, for example, if we had nothing to do, we would either go play on the streets or we would go to the beach or something like that.
Yeah.
We didn't really have toy stores, for example. So we were really focused on enjoying the island.
Creativity,
And
actually.
creativity.
Like creatively coming up with ways
Exactly.
to combat boredom.
Exactly. Yeah.
So did you guys climb trees and battle with sticks? And
Battling with sticks. I remember playing baseball in the forests, using random sticks and throwing rocks at each other. Very crazy.
Sounds like real Caribbean stuff.
Yeah.
Awesome. So during childhood, right, were there any specific moments that you can remember that maybe started to trigger the interest in science?
I think this is going to sound like a big promo for Bonaire, but nature really plays a very big role in the identity of Bonaire, in my opinion, at least.
Yeah.
And because of that, I really saw nature everywhere.
Yeah.
So something that I would really love to do is go to our national park, where it's basically a whole nature reserve. And this is where I sort of fell in love with the idea of nature and things developing. So I learned, for example, a lot about geology just by walking around in that park, looking at the structures, and then also not only looking at the ground, but then looking up into the sky and seeing the stars, and then looking in front of me and seeing the waves. And so all of these different things just all really connected me to nature. And I had this sort of intrinsic feeling that I wanted to understand all of it. And I think being on Bonaire really helped me with that as well.
Yeah. Wow, that's awesome. And I think comparatively, so I know many people in the Netherlands or maybe even in the US, England, wherever they're watching this from, that haven't fully experienced the Caribbean context. They may not understand how the 6 islands are connected, but they're also very different and sort of unique in their own way.
Yeah.
And Bonaire, Saba, and Sint Eustatius are still, well, up to a few years ago, still pretty much untouched.
Yes.
So a lot of the nature was and is still very much highly preserved in comparison with Aruba, Curacao, or Saint Martin even. Where there are spots that are still reserved, but there also has been a lot of development. So I could imagine that the amount of nature interaction was on a high level growing up.
Definitely.
Yeah.
Definitely.
Bonaire is also known for its diving and beautiful underwater nature.
Yeah.
So have you also spent some time diving?
So I'm actually one of the few people who doesn't dive. I love snorkeling a lot. I love looking at the colors and the fish, and I love being in the water.
Yeah.
But I've never been deeper than 3 or 4 meters. That's as much as my body can handle. And then,
Yeah.
But I hope to be able to dive in the future. It's definitely something on my bucket list.
Oh, awesome.
Yeah.
Awesome. So we touched on those early interactions with nature that sort of sparked the interest. So what was high school like? Did you then also study physics and all the science packages?
Yeah, most definitely. So I think when I started high school, I was about 12, and then I had no idea what I wanted to do. I actually thought I would go more into history or something. But then it wasn't until the second year of secondary school that I really realized that mathematics is a lot of fun. And then I was like, okay, I want to do math, or I want to do something related to math.
Yeah.
And then a couple years after that, I found out that you can use math to describe nature, and this is called physics. And that's when my love for physics started, and it only grew since then.
That's interesting, because that initial love and wanting to understand things was born earlier, and then at some point there was a love for mathematics that grew, and then at some point they connected, like, oh my God, these two actually connect, and that's this thing called physics.
Yeah.
So then you went in the footsteps of Mr. Einstein and others, Isaac Newton, and all of those before him.
The giants.
The giants.
Yeah.
I also studied physics in high school. I didn't go as deep as obviously you went, but I know the basics.
And did you enjoy it?
I did enjoy certain aspects of it.
Okay.
Like I really loved the Newton's laws. Like for every action, there's an opposite and equal reaction. Is something that you just see in not only in nature, but just in human interactions on a daily basis. So if you spew out negative energy, you're almost certain to get back that negative energy, and once you're sending out positivity, then you're more likely to receive back positivity, and it's interesting how that dynamic goes. So well, tell us some more about how the interest then was, how it grew deeper to basically lead from high school interest and love and passion to moving on to bigger things.
So I think I must have been around 15 or 16 maybe when I really fell in love with astronomy as well. And then my father told me about this thing called quantum mechanics, which basically doesn't describe astronomy at all. It describes the very smallest, the particles and the atoms and things that we're made out of. And at the time, I thought that there was somehow a link between how the planets, rotate around the sun and how an electron, for example, rotates around the core of an atom. And so I thought, so this way I can look at stars and I can look at the smallest and I can use the same ideas and maybe I'll come up with something new. And this is, it turned out that this is a very, very oversimplified vision of physics. But this made me really want to understand it, because I was like, well, what is this link between the stars and the particles? And then it was a happy coincidence, I think, that in 2012, when I was in the middle of high school, that the Higgs particle was detected at Cern, where I work now. And this is the first time that I really heard the term particle physics. And all I knew about this is that they use magnets to do a bunch of cool things, and you can discover things and find things and play around. And I was like, okay, now I know for sure this is what I want to do. And then the first thing I did is I looked up which universities in the Netherlands can I do this at.
And how old were you then?
I think so. I was about 16 or so.
And in which year were you then? Because what did you do? HAVO, VWO?
I did VWO.
And so you're in VWO what?
I was in VWO 4 or 5. I think. So I already knew at the start of VWO that I wanted to do something physics related, but definitely in VWO 5, I was like, yes, particle physics. This is the coolest.
So how long ago was that?
So this was about 2012, 2013.
So about
12 years ago.
12 years ago.
Or so,
because I'm gonna relate it right now to something very comical. Well, actually, comic book stuff.
Nice.
You know The Flash?
I do.
Have you seen the series?
I haven't actually.
The last couple seasons have been pretty trash, but the first couple seasons were pretty good. And there's a particle accelerator in there, and the particle accelerator is used a lot. In the plot of the series, well, without giving too much away, one of the Flash's enemies, which is Reverse Flash, needed to regain his powers by using the the particle accelerator.
Nice.
So for those that want to have a bit more of an understanding of what he does, but not fully 100%, watch The Flash.
Or also, do you know Into the Spider-Verse? And these they also, the collider actually in the beginning, in the first movie, is based off of one of the colliders that we have.
Oh, wow.
Yeah, so it looks like the exact same model even. So it's inspiring a lot of comic books.
So it's inspired by then, most likely. Okay, so Into the Spider-Verse is one, The Flash is another one. So if you're going Marvel, Into the Spider-Verse, DC, The Flash. Awesome. So you mentioned earlier that your dad taught mathematics and what else?
And computer science.
Mathematics and computer science. So along the way, in those early years of discovery, he also played a major role in sort of helping shape and guide.
I think it was really good teamwork between both of my parents, because my mom was more linguist and humanity based, but she really sort of stimulated my curiosity. And then my father was a bit more technical, so then he stimulated the more mathematics. And so then the curiosity plus the technical bit combined together to form the physics. Basically.
Oh, nice. Awesome. Yeah. So besides your dad and your mom, were there other quote unquote mentors in your life that helped guide you along this path?
Yeah, I mean, definitely the teachers or some of the teachers that I had in high school for sure. It's actually really cool. The physics teacher that was present on Bonaire at the time in the high school, he had a PhD in string theory, which is sort of the top of the line, most physics thing that you can imagine.
Yeah.
And so getting just regular beginner level physics from a string theorist was amazing because he knew everything. He knew all the background information that you needed, everything. So that he definitely was a huge, huge help.
So besides just the regular classes and lessons, would you also go and ask him a bunch of additional questions?
Yeah. And at some point he sent me a link to this website where I could follow a sort of online astronomy course. And then we did that at the same time at some point. And we were like,
cool.
did you look at today's module? Yeah, very nerdy stuff.
So you got to completely nerd out with your string theorist teacher.
Yeah.
So what brought him to Bonaire?
I don't really know, and it's really unfortunate because
I'm just assuming that he's not from Bonaire.
Yeah, indeed. Yeah. He's a Dutch man. Meneer Huiszoon, shout out if he's watching or listening. But yeah, no, I think he arrived about a year or two before I started physics. I started physics in high school, so before I entered the Bovenbouw. And then he also left, I think, 2 years after me. So for me, it was like the ideal timing, but unfortunately, he left afterwards.
I'm shaking my head now because as I'm listening to your story, I know usually those that are very deep into physics and science may not believe in coincidences and serendipity and everything happens for a reason, but that definitely sounds like one of those situations of it happens for a reason.
Could be, yeah. But then it's a shame though because I got lucky, but that means that maybe the people like 1 or 2 years after me missed out, which is a little bit of a shame. Yeah, I think I don't really know what the current state is of the physics teachers there now. But yeah, I think that the Meneer Huiszoon was really, really great. So I think it's sad that he left, unfortunately.
And besides Meneer Huiszoon, are there any other mentors that you can think of right now?
Not a specific mentor, but I think just the general environment was already very stimulating for me. I think people from Bonaire are always trying to root for, go and do your best. Yeah. And then they always say, go and come back. Yeah. The second part, I'm not so sure about at the moment. But they at least go and do your back. You really feel that. You really feel like when you're leaving that people are sort of, you do leave. Maybe you step on the plane by yourself. Yeah. But you feel sort of the island pushing you, but not pushing you away, but sort of helping you.
Yeah. Helping you to make that jump. Yeah. To go out there into the big open world. Exactly. And discover what you need to discover. Exactly. Well, I mean, I've also been here now for 20 years. That time flies by. So I believe that you can give back even without moving back. And especially in the modern age with media and all these different mediums that we have to our disposal, there's lots of ways that we can still connect back to home and give back without physically having to be there. And sometimes it's good that you have your ambassadors all around the world. Exactly. Yeah. So what would you say, what is the importance of having mentors actually?
I think first of all, it's somebody who believes in you so that you know that your dreams are actually possible, that it's not like a crazy fantasy and you're just daydreaming and never going to succeed. Yeah. So I think that's the first thing. And I think secondly,
because were there a lot of those moments where you may feel as a teenager that these are just crazy ideas, and then you would get what's the confirmation? In my head I was going for bevestiging. That you would get confirmation from your quote unquote mentors that keep going on this path.
Definitely. And it's just even very small things where if you maybe say, if you give off the impression that you don't know what you're doing, that, for example, your teacher would be like, oh yeah, no, but I think you're on the right path. And just that little small sentence I think that really does a lot. And especially if it keeps happening, I think it's a very valuable thing for sure. Yeah. So then maybe let's jump to the flip side of it, because
I'm sort of unpacking some other stuff here today.
Uh-huh.
So were there also teachers that maybe were a bit more discouraging rather than encouraging?
Not to me.
We don't have to name any
No,
names. Okay.
not to me, but I have seen it happen to my classmates.
Yeah.
Especially people who had language issues, for example, because that's the whole thing on Bonaire. We don't speak Dutch. I mean, we do, but we don't speak Dutch with each other. We speak Dutch mostly with teachers or in the government or something.
So you spoke Dutch with your mom at home?
Yeah.
Okay, so
Yeah.
that gave you an
That
advantage
helped.
over the
Definitely.
average.
That definitely helped. But I had a lot of friends, also people who come from South America, for example, who still had to get used to the Dutch language.
Yeah.
And I've seen and I've heard stories and I've seen it happen where teachers are just like, oh yeah, no, your Dutch is not good enough. Like maybe you should just, find something else to do so unfortunately that also happened. I don't know what the state is of things now, but at least in my time, this was definitely a thing that was happening.
I've seen that happen in my time as well. I just wanted to touch on it because your story seems to have a few of these key figures that were constant in your life that could constantly give you that encouragement. But I know not everyone has the same experience.
Yeah.
And for those that might be listening that haven't had that experience, just know that. I'll say it, we'll say it, keep going.
For sure, yeah, most definitely.
So let's get into the college time.
Okay.
So when 18 when you came to the Netherlands?
Yeah.
And what was that path like, and what led to where you are today in Cern, which you'll have to unpack in a bit for the viewers, because I don't think the average person knows about Cern.
Well, I'm happy to explain as much as I can. So I moved to Amsterdam in July 2015, and I had just turned 18, so I was really freshly an adult. I mean, now I'm 26, and I don't think 18-year-olds, I don't know if they're really adults, but I thought I was a true adult.
We all did.
Yeah,
and I also look back like 18-year-olds.
Yeah.
You can this out, editor. Y'all don't know yet.
Exactly.
You feel you know everything, but you don't know
You really think you do, but you definitely...
Yeah. It's just beginning.
Yeah. So I was fresh, pipsqueak in the Netherlands. And then thankfully my older brother was already there for a while. He had been there for 2 years. And we lived very close to each other. I said I moved to Amsterdam. It's not technically true for people who live in Amsterdam. I lived in Diemen, which for Amsterdam people that's a real difference. I mean,
for the rest of us, that's all Amsterdam.
Yeah. It's literally like I would walk for 2 minutes and then I'm in Amsterdam. So, but yeah, we lived super close to each other. So that was really nice. So we really had that sort of connection. I really didn't feel very alone because of that. And we had a very big Caribbean community around there too. A lot of people from St. Martin as well, which was really nice. That was actually my first real exposure actually to people from St. Martin.
I could imagine.
Yeah. And then I started my bachelor's. I had no idea what I was getting into. So I was very excited, but I really didn't know what it was going to be like. And in the beginning, it was definitely, I had to get used to it. The first year was a lot of work. We had classes from 9 a.m. up until late in the day. Just the whole structure of the way everything worked was different from high school. I mean, I knew it was going to be different, but didn't know what it was going to be.
Yeah.
And then eventually I moved on to the second year and the third year. And by the third year, things had changed because it got a lot more international.
Okay.
So the bachelor's that I did had a Dutch name, Natuur en Sterrenkunde. And the first 2 years are in Dutch. And then the third year is fully in English, which allowed for a lot of more international students to come and join in on the courses.
Because you did university.
Yeah.
And the first 2 years... How many years was the bachelor?
3.
3 years. Okay.
3.
So the first 2 were fully in Dutch, and then the final year was international.
Yeah. Yeah.
Okay.
And I think that's when things really got different, because I noticed in the first year it was a bit difficult for me to really feel at home with the rest of the students. So, because I think
I think a lot of Caribbean folks can relate.
Yeah, it's really coming here as a person from the Caribbean who already speaks Dutch.
Yeah.
Was very strange, because the Dutch that I spoke it either at home with my parents or at school with teachers.
Yeah.
So my Dutch was fine, but it was really formal. And I wasn't used
Yeah.
to speaking like with young people in Dutch.
Yeah, and speaking in slang.
Exactly.
And, it's like, what do you say?
Exactly. Yeah, exactly. So I would talk to my peers. I would talk to people my age, but I would feel like I'm talking to like older people, adults.
Yeah, yeah.
And that made me feel a little bit uncomfortable, actually, to the point that I didn't really
Interact as much.
Yeah. I would only do like practical interactions where it's like, oh, what was the homework? You know, these sorts of things.
More like work based.
It was more business, not pleasure type of situation. Yeah, and that's why I think in the third year it really changed, because this is when I got more exposed to international people and I could speak English, and I feel much more comfortable speaking English than speaking Dutch.
Yeah.
And then I really feel like life had started.
Nice.
Yeah.
I think a lot of us can also relate to that. Once you start to find your tribes, and your tribes don't even have to be like 100% from the islands, but just, I think also the dynamic once you're away from home and there's many other people that are quote unquote away from their home, then you sort of find this new home together in this new space.
Exactly.
And you tend to look out for each other in a different way. It's a beautiful thing to see that transition happen. So for anyone listening that's now in that first or second year where it doesn't feel there's hope.
Yeah, you'll get there. You'll get there.
So the third year things change, and because so let's, well, after the bachelor's then there's masters, obviously.
Yeah.
So what did you master in?
So my master's now, instead of Natuur en Sterrenkunde, became physics and astronomy. This was a fully a fully English program.
But essentially it's kind of like a direct translation, right? The names of the studies.
Yeah, I also went from the University of Amsterdam to the University of Amsterdam. So it was a pretty seamless transition, thankfully. And also a lot of the same professors, the exact same lecture halls and all these sorts of things. So it was just the courses got more hardcore.
Yeah. So define hardcore.
So now we would have giant homework assignments, for example, after every lecture.
What is a giant homework assignment?
So I remember when I was doing general relativity, which is the theory of gravity and black holes and all of these sorts of things. Like, this is the hardcore physics. I remember I handed in a piece of homework.
You're a real scientist, man.
Oh yeah, for sure. But I handed in a piece of homework that was like 20 pages of handwritten notes.
Wow.
And I feel very bad for whoever had to check that, because my handwriting is not the best. And 20 pages of that. So, and then every week. So
every week.
Yeah.
Wow.
Yeah, that was crazy. Yeah.
So what can you tell us about black holes?
What do you want to know about black holes? I can tell you almost everything, I think.
Oh, damn. Yeah, I'm not that versed in black holes.
Yeah.
Man.
So I can walk you through. So basically, a black hole is one of the final steps of the life of a star.
Oh yeah, it's a dying star.
It's a star that has died already, actually. So at some point, the star, just like our sun, at some point it will run out of fuel, because it's continuously burning fuel. That's also the light that we feel, that we get on Earth. But at some point, it runs out of this fuel, and then there are a few things that can happen. Either it sort of just peacefully dies out, it sort of expands and then cools down, or this won't happen to our sun. It will.
How do you know it won't happen to our sun?
It's hope. No, you can tell because it only happens to very big stars.
Okay.
So
our sun is not very big.
Our sun is pretty tiny, actually.
Oh, wow.
Yeah, our sun is relatively speaking, it's not that cool. It ain't it.
Well, that I did see one of those maybe Instagram posts or something where they were comparing like the size of the planets, and then you had our sun that was looking pretty big relative to the planets in our galaxy, and then it expanded into planets that you probably know that I never heard of, and they just got huge and huge.
Stars can become gigantic. And so when these gigantic stars die, it gets a lot more violent. So our star will just sort of cool at some point and get very calm, and then just fizzle out, nothing will happen. But giant stars, at some point, they will violently explode. and then turn into a black hole. And a black hole essentially is just a very heavy thing that will just continuously attract things through gravity. But once something is beyond a certain point near this object, it can no longer escape. And this is what
it gets sucked in.
It gets sucked in. And we actually don't know what happens after it crosses this.
And that's why
point.
It's called a black hole.
Yes. Yeah. Yeah. And
Crazy.
So an explanation like this would be 20 pages of math, essentially.
Oh, I actually have a crazy question for you. So have you heard of the theories of the Simpsons predicting things?
Oh yeah, I've heard of this.
So have you heard of the one that in an episode a few years back, before I believe was it discovered at Cern? Mm-hmm. Homer actually wrote the God particle on the chalkboard.
It's funny, yeah. My cousin actually sent this to me yesterday. Actually, he sent me like a TikTok with this, and I was like, "What is going on? How did that?" Yeah. So Homer is a genius, I guess. Yeah.
But do you recognize the formula?
Yeah, I think it was real physics. Yeah.
So no explanation for that as yet. Maybe Homer went through a black hole and came out the other side.
Yeah, it could be.
All right. So you wrapped up your master's, and after master's there's the next step of becoming a PhD candidate, right? Could you maybe go into a little bit more details there because I'm also not sure if the average person also truly understands what is a PhD and why would you even want to pursue one? Yeah. So could you touch on that maybe?
No, that's a good question. So essentially, when you're doing a PhD, you're becoming an expert at something. You're becoming the expert at a very, very specific thing. Yeah. So essentially, in practice, what it is you become a sort of mix between a student and a researcher who gets paid, at least in the Netherlands. So it feels very similar to studying, but you're doing actual work. So you're doing research, but you're still in training. And the reason why you would want to do this is because you want to become the expert in something, and then eventually you can continue your career in academia if you want to keep researching specific topics. Yeah. So that's in a nutshell a PhD.
And you're currently doing one. How far along are you? How much more is there to go?
So I am in year 3 out of 4. So I am actually approaching the end, and I'm starting to feel it already. So essentially, at the end of your PhD, you write this giant thesis, which is at least in the Netherlands.
How giant is giant?
You write a sort of book that's between 150 to 300 pages or so, where you basically describe everything that there is to know about your subject, and then very specifically what you've researched and your results and everything that you found and what you can do with it in the future.
And what are you researching for your PhD?
So I'm doing experimental particle physics.
All right.
So particle physics.
Unpack that for us.
Yeah. Particle physics is the study of particles, and particles are basically the building blocks of the universe. So I study the very smallest things. And it's experimental because so you can also do theoretical, which means that you're just making predictions and doing math, pure math mostly. Yeah. But I'm doing experimental. So I'm actually trying to see what comes out of the math and see if we can see it in our real world. And
that goes back to that wanting to understand nature, where you can touch and feel it and make all these connections.
Exactly.
You're like, I'm not just doing the theory alone. I have to see this come to life.
Exactly. Yeah.
Nice.
And so the place where I do this, thank you. The place where I do this is at Cern, which is the European Council for Nuclear Research, which is basically this giant international collaboration. I think it consists of dozens of countries on Earth, where we basically come together to all try to answer questions about these particles. And we have this giant machine called the Large Hadron Collider, which Homer apparently also works on.
So Homer worked on it, but in the Spider-Verse,
they have a copy of it.
Kingpin had one made.
Yeah, exactly.
Because he wanted to travel to another universe to meet his family or to steal his family that was taken away from him in this universe. So are you guys traveling to other universes?
No.
We're not allowed to answer that.
I can. It's classified. No, I can assure you we're not doing anything suspicious, which is what a suspicious person would say. But we're definitely just, we're just trying to figure out what's going on, basically. Yeah. We're just trying to see what's up. So,
how long does Cern exist?
I think it was established in the 1950s.
Okay.
Somewhere, which is actually I think it's really interesting because one of the main goals of CERN is this science for peace idea, which basically means we want to bring people from different countries together to stop fighting so that we can work on something that's good for humanity.
Yeah.
Which is really interesting. If you think about Europe in the 1950s, for example, they were all trying to kill each other in the 1940s.
In the 1940s.
Yeah. And then 10 years later, now they have this like nice grand project where now they're all working together. So I think this is actually a really nice model for the world, essentially, because now we're really, I think we're on all continents except for Antarctica. Although there are some physics experiments on Antarctica.
I was about to say we've seen multiple sort of reports and stuff that there's interesting stuff happening in Antarctica.
Definitely, yeah. Antarctica is definitely a unique place where you can do a lot of cool stuff.
Yeah.
But for now, our headquarters, the headquarters of CERN is based in Geneva, Switzerland, and we have this giant machine where we smash particles against each other.
So I've seen that this smashing of particles happens in a diameter of 27 kilometers or something.
Yeah.
And they're moving. Are they moving at the speed of light?
Almost the speed of light. As close as we can get to the speed of light.
And then smashing these particles into each other. So what type of energy explodes in such a moment?
Yeah. So to get very technical, I maybe for people doing high school right now, they might recognize, but so the energies we reach is 13.6 tera electron volts, which, in terms of normal speak, this doesn't mean anything, but it's in terms of a single particle, this is an extreme amount of energy.
Tera electron volts?
Yeah.
Okay, so do we have any electron volts in just regular everyday life? Is that like the 120, 220?
So essentially this is another version of joule. So, okay. If you have a light bulb that's 50 joules per second, for example. So I think, I don't know from the top of my head, but it's comparable to, for example, a baseball thrown by a pitcher, but then a baseball is a really big object, consists of a lot of particles, so that energy is distributed. But it's the amount of energy that baseball would have, but focused on one single particle instead of the hundreds of billions. So it's actually for one single particle, this is a lot.
So
of
the
energy.
Baseball has hundreds of billions of particles.
Yeah.
And then the energy that would have focus on one single particle.
Yeah.
Okay.
Yeah. So it's a totally different energy scale than we get in our daily lives. And the reason why we do this is because we want to, when we smash these particles against each other at these giant, heavy speeds or high speeds, we want to break them apart. So we want to see if we can really ramble the proton hard enough so that it falls apart, and then we can really study the insides of protons.
So break this down again for the science dummies in the room, aka me. Well, I know we have because we actually use this theory in design as well. Atoms, molecules, organisms, etc. But the protons and neutrons that is within an atom.
Yeah. So if we start from sort of our regular experience, so you have humans, and then if you zoom into a human, you see cells, which forms biology, and if you zoom into a cell, you see molecules, which forms chemistry, and if you zoom into molecules, you get atoms, and now you're getting close to the fundamental structure. So if you zoom into an atom, you see that you have protons and neutrons, and then if you zoom into that, this is sort of the exploration territory inside of protons and inside of neutrons.
So the inside of the protons and neutrons is sort of the black hole that is still undiscovered field.
In a sense.
And that's where a lot of the experimentation is happening to understand what is happening at that subparticle level.
Yeah, or subatomic level.
Subatomic level.
Yeah.
Okay.
Yeah.
Hey, I'm learning some stuff. Nice. Awesome. So what would you say has been your most exciting discoveries or breakthroughs throughout your career thus far?
Ooh, that I've made personally or that I've just witnessed?
Both. Let's start with you personally.
Okay, personally, I think just finding out. So one really crazy thing I think is the theory of relativity, which is something that Einstein came up with a bit more than 100 years ago, which all has to do with time and space.
Yeah.
And essentially, one thing that I found out eventually is that time is not really as understandable as we think it is, because time can move very fast if you're in a very specific situation, or it can move very, very slow if you're in a different situation.
And it's funny because I think a lot of people have felt that throughout their lives at different points. Like, yo, time is moving fast. And then like, things are just going slow.
Yeah.
But then the general knowledge that we have on time, no, time just moves in one way.
Yeah. So it's so what you mentioned is more of a, I think, psychological thing. But it's actually a little bit comparable. So if, for example, we were to both start a timer on our watches at the same time, and then I fly into a spaceship and I move very close to the speed of light, and then I talk to you, and then I stop, and then I talk to you afterwards, or I don't even stop, but I communicate with you somehow, and I'm still moving very fast. And I tell you, okay, for me, I've been in the spaceship for about 10 seconds. Then you will tell me, like, no, you haven't been. This hasn't been 10 seconds. It's been 5 years.
Oh.
So it turns out that if you're moving very quick, time slows down for you, which has really, really strange consequences if you think about what that means for the universe, that time is not really a fixed thing. It's relative.
Yeah.
And I think this is why it's also called the theory of relativity. And this for me was a really mind-blowing thing, because it just the whole idea of what time is was totally flipped for me.
Because what you describe now, I have seen in different sort of science fiction movies. So I guess that's where that theory comes from that they apply there when super interesting.
Yeah.
Let me don't unpack that further. So that's one of your personal breakthroughs, and then one that you've witnessed.
I think the discovery of the Higgs particle. So I was in high school when it happened, but my supervisor, for example, and a lot of people that I work with today are people who were actively involved in discovering this particle.
Yeah.
And it was such an amazing thing because thousands of people worked together to find this thing. And it was predicted in the 1960s, and they actually managed to find it.
Oh, wow.
Yeah. And they all have their own story of, where were you during the discovery? And that was just so amazing to see. That something that you just predict, some people just wrote something down on a piece of paper once, and then about 60 years later and a couple billion euros later, you actually find...
Don't forget the billions of euros.
Yeah.
So we spoke about the 1950s. That CERN started in the 1950s. CERN is... What's the acronym stand for?
So the translation in English would be the European Council for Nuclear Research.
For nuclear research. So there were some other nuclear events that took place in the 50s.
Yes. Yeah.
Christopher Nolan, one of my favorite directors, finally won his first Best Picture Oscar for this movie. And for those that haven't guessed as yet, we're talking about Oppenheimer. So as a physicist working at CERN, what were your personal thoughts about it? And what were sort of the community collegial thoughts about the movie?
I really, really liked Oppenheimer. I think you're a little bit of a comic book nerd or fan. I call it amongst my friends. I call it like the Avengers of physicists.
Dun, 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 dun.
It's so awesome because the movie has all the characters in it are real historical people that I've been reading about. I've been reading their theories, working with their actual formulas, all of these things. So these are people that I've been hearing about for the past couple of years. And then to like see them on the big screen now, and then also see the personalities that I heard that they were, and I just thought it was really awesome. I really, really love that movie. Yeah.
You know what just hit me? They actually went and got an Avenger to put in the movie.
Which one?
Robert Downey Jr.
Oh,
Tony
yeah,
Stark.
right. Yeah. Right. Yeah. Yeah. Yeah.
But he was playing a physicist, right? Just not a good one.
No, he was like a congressman or something.
Oh, a congressman. Okay, yeah.
Or something like some government man.
Yeah, some government man. Those government men. So they didn't want to make him an actual physicist Avenger. He just got to be on the sidelines.
It was too much overlap between the worlds.
True. That might have caused what was the hydro collision? Cause a black hole in the space-time continuum.
Really mess up the universe.
So what was like the collegial discussion? So the discussion amongst your colleagues?
Before it came out, we were all like, we were waiting for it. We were like, oh, how's it going to be? Because obviously we were all going to watch it. And then it was in the summer, so this was perfect. We all had like tiny breaks. We all split, and then we reconvened at some point, and we were like, okay, did you watch it already, or are we going to watch it together, or like what's going to happen? And obviously it was mandatory almost for us to watch it because it feels like it's about us.
Yeah.
Because these are physicists. I mean, they're our predecessors. So essentially the Manhattan Project, the project to build the atomic bomb, is actually the first big collaboration between giant physicists
from all around the world.
Well, in this case, it was mostly centered around the U.S. because of the war and stuff. You couldn't really do international things so well. But at least, all these famous physicists coming together to do a physics project. This was the first time that it happened at this scale.
But Oppenheimer, what is his background? Because not.
So he was a theoretical physicist.
Yeah, I mean background as in nationality.
American.
An American, 100%?
Well, maybe. I mean, probably down the line somewhere, his ancestors.
Okay.
But I think he was just born, I think, in the U.S.
Because weren't there any physicists with like European backgrounds also on the Manhattan Project?
Yeah, so these are people who had emigrated or actually had fled Europe. I think there were a couple of Italian people like Enrico Fermi, for example, who is in our field. He's extremely famous. There's even a whole lab named after him. So he's Italian, for example, and he was also part of the Manhattan Project. Yeah, so I guess it was international, but not in the same sense that governments are working together, but it's
because it was different times. Governments were fighting against each other at the time. Let's hope we don't enter that type of zone again.
Exactly. But that's what. But so Cern is kind of the successor of this.
Yeah.
I mean, okay, the Manhattan Project was to build weapons.
Yeah.
Thankfully, we've moved away from that now, and now we're building. I mean, Cern has nothing to do with weapons.
Yeah.
But it's the same sort of idea of this international collaboration of all these,
great minds coming together.
Yeah. Exactly. So we really, at least when I was watching the movie, I could really recognize a lot as well. So I recognized what happens if you put a bunch of physicists together in the same room and the types of discussions that you would get, and you'd see.
So these are similar discussions that you're having today?
Yeah, for sure.
Almost 100 years later.
Yeah, for sure. And also the ego clashes that happen sometimes. All of that, I think, was very, very true to nature.
So were there any specific characters in the movie that you feel you relate to a bit more?
I think, well, it might sound a bit weird, but actually some parts of Oppenheimer himself I could relate to. Because in the movie, something that he focused on at some point, that he said he wanted to bring physics to a place that he loves. Like he wanted to build a lab in this case, it was New Mexico, because he really likes the environment there. And when he said that actually really resonated with me, because I would love to bring physics to the place that I love as well, which is Bonaire. Yeah. So I would love to make like some kind of physics project on Bonaire. I mean, obviously nothing to do with weapons, especially no testing of
For peace.
weapons. But yeah, peaceful purposes. But yeah, bringing physics or making a giant physics lab on Bonaire or something, I think that would be really amazing.
Awesome. So if we're looking into the crystal ball of the future, you're 26 right now. What would 36-year-old Dylan be doing?
Ooh. So I think 36-year-old Dylan... So 26-year-old Dylan wants 36-year-old Dylan to be... I would like to be a professor.
Okay.
Yeah. I would want to really teach the next generation. And I'd also like to very actively be involved in research still.
Okay. So it's kind of like that combination of being a professor, teaching the next generation, but also still heavily involved in research where you can help create the next breakthroughs.
Exactly.
Because that's also very much a thing within your field, right?
Most definitely. Yeah. I mean, we're making history all the time at Cern. So I definitely want to contribute more to that. And something else that 26-year-old Dylan wants 36-year-old Dylan to do is also hopefully be a professor to other Caribbean people. Because there is quite a lack of Caribbean people or even people of color in general, I think, in my field.
Yeah.
And I would really love it if that changed.
So when we talk about being a professor, then you do mean at university level?
Yeah.
Okay.
Yeah.
Because it did dawn on me that you said it's a pity that the teacher left. It's like, hey, there's a potential opening, but I understand you want to also be working on research simultaneously, and that'll be a lot more difficult from based from the Caribbean. But maybe there's some summer projects. Who knows?
Yeah, I would definitely be very interested to do some projects going back to the islands and including them a lot more in discussions and in learning and maybe summer schools or something, summer camps maybe even. I think that would be really, really cool.
Yeah, for sure. So you mentioned that you're also an advocate for spreading the word about the awesomeness of science, physics, etc. amongst Caribbean people. Could you give me some examples of that?
So I really like to go to schools, high schools. I did it last December when I was on Bonaire. I passed by my old high school. And then I basically tell people about physics. I show them some really cool pictures, and I show them how our machine works and all these sorts of things. And then I walk them through how to get there, basically. How do you do a career in something like this? So, yeah, I think talking to young people is one of the very important things to do in that regard.
So it would be pretty awesome if 36-year-old Dylan has these stories of people coming up to him years later and saying, that time you came to my high school, this is why I'm here now working on the next black hole discovery.
That would be amazing. That's truly the dream, honestly.
Let's put that out there in the universe. So this actually segues into one of my classical questions. What advice would you give 18-year-old Dylan?
Okay.
Looking back at where you're at today.
Yeah. I think number one, I would just say, in Papiamento, I would say, Sigi Lucha.
Sigi Lucha.
Yeah.
Just what does Sigi Lucha mean?
Keep going. Keep fighting. Keep the motivation, because eventually you'll get where you want to be.
Yeah.
I think, I don't know, 18-year-old me, I don't think I expected to be where I am now. I'm honestly,
I could imagine.
Impressed myself.
Because being at CERN, is there any other, has there been any other Dutch Caribbean based scientist, physicist that has worked there before?
As far as I know, no, I don't think so.
No shit.
I've been looking for them. I haven't found them. So I think I might be the first one. Yeah.
And if not the first, then definitely one of the very, very few.
Yeah. But hopefully not the last.
Hopefully not the last. You're inspiring the next generation.
Exactly.
To come.
Yeah.
Awesome.
Yeah.
Amazing. So if we look at this other viewpoint, right? by being one of the first or the first Dutch Caribbean based physicist at Cern currently, how do you think your Caribbean background has sort of influenced the way that you work?
Oh, I really love that question. I think so. Something that I really notice when I compare myself to my more European colleagues is I have a very strong sense of community. And I think this is just something I grew up with. We always have this thing where, even if we're not related, we still feel like family, and we really look out for each other, and we help each other, and we make sure that nobody gets left behind. I feel like I miss that a little bit in Europe.
Yeah.
And I noticed this also when I'm working in teams at Cern, that I tend to try to sort of group people together and really help the team working aspects a lot better. And I think that, coming from the Caribbean is the reason why I do that.
Oh, wow.
Yeah.
Awesome. Have you ever heard the term emotional intelligence?
Mm-hmm. Mm-hmm.
So we have the IQ, but there's also the EQ.
Yeah.
And I've said it many times that I believe we from the Caribbean, we tend to have a higher EQ than let's say the average, due to this smaller community.
I can see
aspects.
that. I can see that for sure. I think we really have a lot more sympathy and empathy for each other.
Yeah.
And this is definitely, I can totally see what you're saying.
Could you share any particular example of where your EQ played a significant role in solving a challenge in those environments?
So I think so often, so since I'm working in a giant collaboration, I have about 3,000 direct colleagues, more or less, doing the same thing.
So you have about 1/4 of Bonaire.
Yeah.
But you're used to that then.
Honestly,
small island communities.
Cern does feel like a little bit of an island in that sense. Yeah,
it's 27 square kilometers.
But because of this, so essentially, working together is extremely important.
Yeah.
Especially if you're this many people, because you need to make sure everything's working correctly, and also everybody has their own goals, and thankfully we do split up. We do split up into smaller teams, of course, because one giant team of 3,000 is just not possible. But I do actively try to assemble teams, and I do look at the different skills and strengths and also weaknesses of people that I work with, so I can be like, okay, I try to delegate a little bit. I think, you might be better suited here, and then maybe you can work on this, you can look at that. And I think that's where my EQ really comes into play.
Oh, nice.
Yeah.
So are you in a bit of a leadership position, or this is just more the natural progression due to the EQ?
Exactly. Yeah.
And picking up the torch that no one else wants to pick up.
I think I tend to take the initiative on these sorts of things. Yeah. I just really like to see people working together and getting along. And I found out that's not everybody has that opinion.
It's always interesting to see how those Caribbean superpowers emerge in the big wide open world. Awesome, man. Dylan, it's been a joy and a pleasure talking to you.
Likewise.
And, I felt like I've brushed up on my physics a little bit.
Amazing.
Learned some new interesting things along the way.
Nice.
Is there any more specifics that you would like to share with the people listening, watching?
Well, if you're more interested in physics and certain things, particles, black holes, stars, the universe, I actually have an Instagram page, which I've opened recently. It's at Dylan the Boson. And I have one video up already, but I'm going to make a couple more where I really show sort of the ins and outs of Cern.
Wow. Awesome.
And more cool facts. Also, for example, maybe a more in-depth explanation on what black holes are and these sorts of things. So have a follow and keep an eye out because cool things are coming.
Awesome. So we'll make sure to put that link right here and in the description below.
Yes, please.
And who knows? Maybe in a couple of years' time we'll be back here or somewhere else chatting up on what is actually in those neutrons and protons in the subatomic particle.
Yes. Yes, the subatomic particle level.
Yes.
Yeah, I'd be
Awesome.
totally down.
All right. Thanks a milli for coming.
Yes.
Pleasure
Thank you very much for having me.
And for the folks at home, well, you know what to do. Like, subscribe if you haven't subscribed yet. And place a comment below. Like, is there any particular questions that I may have missed? Well, if you want to see more about Dylan, we'll include all of his links in the description below. And another awesome one, man. We have someone from the Dutch Caribbean doing subatomic particle research. Like, can you imagine? Clap it up for the Dutch Caribbean, man.
Yes, for sure.
Awesome. Thank you.
All right.
See you in the next one. Bless.